So in these examples, we are going to be factoring these expressions here by grouping. And don't forget, factoring means taking an algebraic expression and turning it into a product of expressions. And we're going to do that by grouping these. Now, you could only group these four-term expressions. As you can see here, this expression has four terms. So when we group them together, what we'll wind up doing is we'll wind up factoring the individual groups. So I'm going to rewrite this expression here. X squared plus 2x plus 3x plus 6. So if I group the first two terms together, the x squared plus 2x, so I'm just going to put a little grouping symbols around here, just like that. And then I'm going to group the next two terms together. Now when you group them, always include the sign within that first term there of the group. Always include it in there. Now we're going to factor the individual groups. So for x squared plus 2x, what's in common between these two terms? Well, there's an x. So I'm going to factor out an x. And what's left? Well, x plus 2, and we can check. X times x, that's x squared. And x times 2, that's 2x. We'll do the same thing with the other group. We can see we have positive 3x plus 6. What's in common between the two terms? 3. A positive 3, so we'll pull out a positive 3. What's left? X plus 2. Now the whole idea when we go ahead and we factor by grouping is hopefully that when we factor, we wind up coming up with a common factor. For this particular one, it's x plus 2. So we took this four-term expression and turned it into a two-term expression. This is one term, x times x plus 2, and this is another term, 3 times x plus 2. So as you can see, we have something in common between the two terms. What do we have in common between these two terms? X plus 2. So we'll continue with the factoring process. So we'll factor out x plus 2. And what do we have left? X plus 3. So x plus 2 times x plus 3 are the factors of x squared plus 2x plus 3x plus 6. Don't forget, factoring means taking an algebraic expression and turning it into a product of expressions. Product means multiplying. That's what we did here. Now we can go ahead and we can check to see if that's correct by using FOIL. We'll use the distributive property using FOIL. So we'll use FOIL to check. So we'll do x times x. That's the first of our FOIL. And x times x, that's x squared. O, that's the outer terms. X times 3, that's 3x. 2 times x, those are our inner terms. That's 2x. And 2 times 3, those are our last terms. That's 6. And these terms are the same terms in this expression as we have up here. So I think we're good. We're going to do the same process for this expression down here. So I'm just going to copy it down. X squared minus 7x minus 6x plus 42. Again, we'll group together the first two terms and then group together the second two terms, always capturing the sign attached to that first term of the second group. Now we'll factor the individual groups. X squared minus 7x, we can factor out an x. That leaves us with x minus 7. And over here we can factor out a negative 6. So I'm going to factor out a negative 6. And I'm left with x minus 7. The objective here is to, when we go ahead and do the factoring here of the individual groups, we end up with common factors again. And we could check them. X times x, that's x squared. X times negative 7, that's negative 7x. Negative 6 times x, that's negative 6x. And negative 6 times negative 7 is 42. And as you can see, we have a common factor again. That's x minus 7. And we're left with x minus 6. Again, we can use FOIL to check. X times x, x squared, x times negative 6, negative 6x, negative 7 times x, negative 7x, and negative 7 times negative 6, 42. And of course, all the terms for this expression match all the terms for this expression. So I think we got it.